All right, so for this video lesson, we're going to be learning about estimating roots. So we're going to learn about cube roots, fourth roots, continue to practice with square roots. Other topics we're going to see in chapter 4 is types of numbers, so exact and approximate numbers, rational and irrational numbers, integers, real numbers, whole numbers, etc. Towards the end of this chapter, we will start working into exponents and operations on exponents. And that's about it for chapter 4. So without further ado, we will get going with estimating roots. Okay, so before we get going, just a review of radicals. So remember, the whole thing up here is called the radical. Okay. What is underneath the square root sign is called the radicand. And what root we are taking is called the index. Okay. If we do not see a number there, it is assumed that we're taking the square root. If there's a 3 there, we're taking the cube root. If there's a 4 there, we're taking the fourth root, etc. If you are taking the fourth root or higher, on your scientific calculators, if it's a Texas Instrument, you press the math button, and there's a little exponent with an X in front of it. And the X will be whatever index that you are taking. Okay, so since 3 squared is the equals 9, 3 is the square root of 9. So we write 3 is equal to the square root of 9. 3 cubed is equal to 27. So in other words, 3 is the cube root of 27. So we write 3 equals 3 cube root of 27. Okay, so just rolling with that. Since 3 to the exponent fourth is equal to 81, 3 is the fourth root of 81, and we write that as 3 equals 4 as the index root 81. Okay. So how would we write 5 as a square root? Okay, so what times what? Or 5 times 5 equals 25. So the square root of 25 is equal to 5. Okay, so cube root is something times itself 3 times. So 5 times 5 is 25. Times 5 more is 125. So we say the cube root of 125 is equal to 5. Okay. So as a fourth root, so it's just a number times itself 4 times. So 5 times 5 times 5 is 125. Times 5 more is 625. Okay, and we are taking the fourth root this time. That equals 5. Okay. So here is a chart. It's comparing radicals, values, if those values are exact or approximate, and if that value is rational or irrational. Okay. We're going to learn a little bit more about rational and irrational numbers next lesson. But for the purpose of right now, if the value terminates, so for example, this first one, the square root of 16 is 4. Because there's no decimal that continues on forever, we say this is an exact value. And because any exact values are going to be rational numbers. Okay, so if it's an approximate, we will consider that irrational. Okay. So if we take the square root of 27, put that into your calculator, and it comes out as 5.196 and a whole lot of numbers at the end of that, okay? So because that is a non-terminating decimal, we say this is an approximation. Okay, and approximate numbers are irrational. Okay, so if we are taking the square root of a fraction, we do want to simplify this fraction as much as possible first. Okay, so if we're square rooting a fraction, we can simplify that to taking the square root of the numerator, so square root of 16, and also taking the square root of the denominator. Okay, hopefully these numbers are familiar to you guys. So the square root of 16 is 4, and the square root of 81 is 9. Okay, so if you were to put this into your calculator, it would be a repeating decimal. Okay, also anytime that we can represent a value as a fraction, it is also going to be an exact value. Okay, so oftentimes in math, we will, instead of converting a fraction to a decimal, we will just leave the answer as a fraction because that is a more exact answer than a rounded or an approximated decimal. Okay, so exact values are rational. So if we can represent something as a fraction, that is rational. Okay, so the square root of 0.64, so 64 hundredths. This can be represented again as a fraction as the square root of 64 divided by the square root of 100, which is equal to 8/10. So again, if we can represent it as a fraction, it's exact. And if you want to go one step further even, it is a terminating decimal, 0.8. So this is an exact value and rational. Okay, so now that we've done the first 4 together, I would encourage you to try the next few on your own, and then come and check my work here once you have tried a few on your own, okay? But I'm just gonna keep rolling here. So the cube root of 16, I put this into my calculator. We can't really simplify that. And we get 2.519 and a bunch of other decimals. So that is an approximate and irrational. Okay, the cube root of 27 is 3. That is an exact value. So that is going to be rational. Okay, I'm just gonna pop a line in right there. So the cube root of 16 divided by 18. Okay, so again, we should rewrite this as the cube root of 16 divided by the cube root of 81. Okay, punch those into your calculator and we get 2.519. A bunch of decimals. Okay, so not a whole number. And 4.326 and a bunch of numbers. So because we are dividing two approximate numbers, our number will also be approximate, okay? Approximate and irrational. But if we were to be dividing two rational numbers, like we did up here, 4/9, that would be a rational calculation there, okay? So take the cube root of 0.64. Could also be the cube root of 0.64 divided by 100. That gives us 0.8617, bunch of decimals. So that's an approximate and irrational. Take the cube root of negative 0.64. We're going to get that same number, but just negative actually. We will talk more about cube rooting negative numbers later on. Okay, the cube root of 16 is 2. That is exact and rational. Okay, hopefully you're starting to get the hang of this. The fourth root of 27. Try putting this one into your calculator. Hopefully you get 2.279 and a bunch of decimals. Approximation, irrational. And this last one here. So cube root of, or sorry, the fourth root of 16 divided by 81. Anytime you see something like this, try to take the fourth root of the numerator and the denominator separately. Okay, because this will come out as 2/3. Anytime we have rational numbers as a fraction, those are going to be exact values and will be rational. Okay, so the big thing here is, well, one, entering cube roots and fourth roots into a calculator. Also simplifying radicals, like if we're trying to divide or taking the cube root of a fraction, we should always try to simplify or take the index of the radicand before of the numerator and the denominator separately. Okay, so one of the things you're gonna have to do throughout this chapter is estimating radicals. And easiest way to do this is just set up a number line, okay? So we're doing a perfect square number line first. We're going to do a perfect cube and then a perfect fourth next. And when we do this, so just on the top, let's just do the numbers, okay? So just a regular number line, excuse me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, okay? And then on the bottom, let's write the roots. Okay, so 1, how do we get 1? So the square root of 1 equals 1, okay? The square root of what equals 4? So, or 2, excuse me. So I think the easier way to do this is to multiply up. So 2 times 2 is 4, so root 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25, etc., etc. So 6 is 36. Oops. 7 is 49. 8 is 64. 9 is 81. 10 is 100. And 11 is 121. Okay, so now we're going to estimate where root 20 is approximately. Okay, so if you're asked to do this on an assessment and you just punch this into your calculator, I'll tell you right now, I'm going to give you 0 marks. Okay, you have to show your work, use a number line. Okay, but root 20, okay, so that's going to be somewhere in between root 16 and root 25. And because 20 is closer to 16 than it is to 25, just by a little bit, it's going to go just a little bit on the left side of that in between 4 and 5. Okay, so I'm going to say root 20 is approximately 4.4. Okay, and these are just estimates, so I don't need them to be perfect by any means, but it's just more of mathematical reasoning and estimating. Okay, so this next one is going to be root 8. Okay, root 8 is closer to 9 than it is to 4, so I'm going to kind of put it a little bit closer to root 9, and I'm going to say root 8 is approximately about 2.8. Okay, lastly, root 76. So that's going to be somewhere in between root 64 and root 81. 76 is closer to 81 than it is to 64. So I'm going to put that a little bit closer to 9 than it is to 8. And I'm going to say root 76 is approximately 8.7. Okay. So that is how you estimate radicals. So just set up a number line and then just go from there. Okay, so that one is for perfect squares. This one we're going to do next is for perfect cubes. Okay, and we're going to set it up the same way that we did before. So we will put our numbers on the top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then we're going to be doing our perfect cubes on the bottom. Okay, so 1 times 1 times 1 is 1. Okay, and I'm just gonna be lazy here. All right. So same thing. So 1 times 1 times 1. So 1 is the cube root of 1. 2 times 2 is 4. Times 2 more is 8. 3 times 3 is 9. Times 3 is 27. And we will continue. So 64, 125, 216, 343 for 7, 512 for 8, 729 for 9, 1,000 for 10, and 1,331 for 11. Okay. And same thing. So we're going to look for root 16 on our number line. Okay, so that's going to be in between 8 and 27. And 16 is closer to 8 than it is to 27. So I'm going to put that in around here. And I'm going to say the cube root of 16 is approximately 2.4. Okay, and I'm not going to be too picky here. As long as you're within kind of that right side of half, you'll be in good shape. Okay. For example, like if you were to say that was 2.6, because 16 is closer to 8 than 27, I might dock you half a mark or something like that. Okay, so just try to be within or on the right side of a half. Okay. So cube root of 27, that actually is right here. That's an exact value. So that is equal to 3. That was nice and easy. And last one is cube root of 180. So that is between 5 and 6 somewhere. And 180 is 36 away from 216. And it is 55 away from root 120 or cube root of 125. So I'm going to say that's a little bit on the closer side to 6. Okay, so I'm going to say that's about 5.6. All right. So next we're going to do a perfect fourth number line. So I would encourage you to pause this video now and go ahead and try to do this one on your own. And actually, let's just do this one up to 4. Okay, so 1 is still the 4th root of 1. The 4th root of 16 equals 2. The 4th root of 81 equals 3. And the 4th root of 256 equals 4. Okay, so we are looking, first we'll do the 4th root of 20. That is much closer to 16 than it is to 81. So I'm going to say that one is approximately 2.1. Cube root of 27. Again, much closer to 16 than it is to 81. Not as close as 4th root of 20 though, so I'm going to say that's about there. Let's go for about 2.2. Okay, the 4th root of 65. That one much closer to the 4th root of 81 than the 4th root of 16. So let's say that one is approximately 2.8. All right. So be able to create a perfect square or a perfect cube or a perfect fourth number line. Okay, so referring to our number lines, now we're going to determine or estimate these values here. Remember, anytime we are dealing with radicals with fractions, we should always try to simplify the numerator and the denominator separately. Okay. So we'll start with the square root of 16 divided by 81. So break that up into the root 16 divided by root 81. You might not even need to use your number line for this. So square root of 16 is 4. And the square root of 81 is 9. Okay. So there's that. And that just kind of simplify this as much as possible. Okay. So the square root of 0.64. So if we jump back to our number line, let's use our number line for that one. Definitely going to be less than 1. But let's go ahead and simplify this like we did earlier. So this can be rewritten as the square root of 64 divided by the square root of 100. Remember 0.64 is 64 hundredths, okay? Which can be written, square root of 64 is 8, square root of 100 is 10. And if we change that into a decimal, 0.8. Look at that, less than 1. Okay. Let's continue. So the cube root of 16 divided by 81. So again, let's take the square root of the numerator and the cube root of the numerator and denominator separately. So that equals the cube root of 16 divided by the cube root of 81. Those are not perfect cubes. So let's jump back to our number lines. So cube root of 16, we already said that was approximately 2.4. And the cube root of 81, pretty close, pretty much in the middle between 4 and 5 there. So we'll go for approximately 2.4 divided by 4.5. Okay, and try this last one on your own. That'd be great. It's a decimal, so we can rewrite it as a fraction. So that's going to be the cube root of 64 divided by the cube root of 100, right? 64 hundredths. Jumping back to our number line. So cube root of 64. Well, that's actually a perfect cube. So that equals 4. And then the cube root of 100 is closer to cube root of 125 than it is to cube root of 64. So let's say that's approximately 4.7. So it's approximately 4.7. All right. Okay, so what types of radicals cannot be evaluated or estimated? Yeah, good question. So go ahead and pause this video, chat with your peers, and then come back when you have discussed that. But yeah, so those types of radicals that cannot be evaluated, so we cannot take the square root of a negative number. Okay. Cannot take the square root of a negative number. Yeah, so we can only take the square root of positive. So for example, the square root of 64 could be positive 8, or it can also be negative 8, right? So remember, negative times a negative equals a positive. There is no way to get a negative number by multiplying itself by itself, right? It will always come out positive. Okay. However, we can take the cube root of a negative number. Okay. Okay. And that is because we might have negative 8 times negative 8 equals positive 64. And then don't forget you have to times that by negative 8 one more time. So let's see what the cube root of 8 is. So 512. Negative 512. Okay. So the cube root of negative 512 is equal to 8. Because if we multiply a negative number by itself 3 times, it will become negative again. So we will learn more about that as we continue on with this unit. But that's it for topic 4.1. So go ahead and take a break, and then please go ahead and start watching 4.2, irrational and rational numbers. Thanks so much.